Now, LEDs are very useful in the school lab. I'll be showing you two applications that are great learning tools for students. They both involve very low currents. So ordinary globes just won't light up. You need the little LEDs when you want to see if there's current flowing or not. So how to use them in a circuit? Firstly, since diodes will have current only one way, you need to connect your LED so that the long end of wire, which is the positive end, is connected to the positive terminal of your voltage supply. Secondly, since LEDs have very low resistance in the forward direction, you need a resistor in the circuit as well as the LED. You can see the symbol for a diode there in the rough circuit diagram that I've done. The positive end is the triangle end, and the negative is where the straight line is. And the symbol for a light-emitting diode is the same symbol but with a couple of arrows coming out of it, as you can see in the top left. Now you can easily buy LEDs from Jaycar or similar stores. They're not very expensive. So what you need to do is look up its bias voltage, which is the threshold voltage, that minimum voltage you need to get it working. And you look up its forward bias current, which just means the normal operating current for that LED. And it will probably be about 10 to 20 milliamps, unlike the little globes that are working best on about an amp at least. You can use an online calculator like the one that I've got the address for on the screen. You plug in the threshold, the bias voltage, and the bias current, and it will tell you what resistance you should have in the circuit with it. One learning tool I found to be a great success, especially with junior classes, is Squishy Circuits. It was developed by the University of St. Thomas. They give full instructions and a recipe for making conductive dough, which is very similar to the conductive putty I used in the POE exercise for resistivity of different shapes. Because it's essentially a semiconductive material, the dough acts as wires but also resistors, so the current through these squishy circuits is very small. That means that you need LED lamps to see whether there's current or not. It also means that you don't need to add any extra resistors to this circuit because that resistive dough has got plenty of resistance. You typically need a voltage of 2 to 6 volts, depending on how many blobs of dough you have in series. The website that is listed there gives a lot of detail about how to use the circuits. Another great way to let students explore circuits is with lemon batteries. All you need is a lemon, or a piece of one, and two different metals, typically a bit of copper wire and a zinc galvanized nail. That will give you about a volt of output. But they have a very high internal resistance, which means that while you might get a volt out, the current will be very small. That's why you need LEDs for these, because they're the only things that will light up with that low a current. And of course, again, because the current's low, you're not going to need any extra resistors in these circuits. However, the bias voltage of the LEDs of about 2 volts or so means that you'll probably need at least 2 lemon batteries in series, and that way their voltages will add up. They can also be connected in parallel. And so this is a great way that they can investigate the internal resistance of collections of voltage sources, because the internal resistances will add up as resistors in series or resistors in parallel. So students can investigate the current and voltage from different arrangements of lemon cells and measure the internal resistance of the lemon batteries in series or in parallel. So many devices need DC, and that includes anything that contains electronics, such as any computer device, TVs, anything with a computer in it. So these all have little boxes inside them that contain rectifying circuits. You might have seen the transformers and rectifiers if you've ever had LED lights installed in your house. So all of these need rectifiers. Rectifiers are the things that change AC to DC, and their basic component is the diode. If you look at the circuit at the top, we have one diode and an AC input. The diode lets the current through for the positive section of the voltage cycle, but blocks it for the negative because of its high resistance in the reverse direction. This leads to an output that mirrors the input voltage for the positive parts and is zero for the negative parts. This counts as DC because it is in one direction only, but it doesn't look very nice. The way to make it smoother is by using a capacitor. Because capacitors store energy while the voltage is high and release it when the voltage is low, they are ideal for smoothing circuits in rectifiers, and this is one of the main uses of capacitors commercially. So you can see that the output voltage, including a capacitor, looks like the dotted line at the bottom right, that is fairly constant but with a slight wobble at 50 Hz. If you want to get more complicated, or if students are interested, there are also full wave rectifiers that have slightly more complex circuits, and you can look those up.